Hi students, in this video we're going to go over section 4.5 Venn diagrams. So our goal is just to discuss Venn diagrams and be familiar with how to use those. So Venn diagrams are a useful technique for illustrating the relationships between sets. English mathematician John Venn was the one who first introduced these diagrams in 1881 in his book on symbolic logic. A rectangle usually represents the universal set, and you may remember from a previous video that the universal set is the set that contains all the elements for discussion for a particular problem. Subsets of the universal set are usually represented by circles. So over here we have some examples. At the bottom here you have this rectangular shape. You have U here indicating that that's your universal set. And then inside that universal set, you have another set represented by the circle. And that circle, since it's inside the rectangle, that circle represents a subset of the universal set. And it'll be labeled, so you have A here, so that's set A. Over here you have another universal set. You have your U here indicating you have a universal set. And then inside that universal set you have a couple circles. So you have this blue circle, it has A here, so this is set A. You have an orange circle, it says B here, so that's set B. And both set A and set B are subsets of the universal set. Venn diagrams with two sets. So two sets may be represented in one of the following ways depending on the relationship. So we're going to go through each of these Venn diagrams, each of these images. So the first one represents equal sets. So if set A equals set B, then you just have this one circle here inside of your universal set. So here A equals set B. That's what it'll look like if A and B have exactly the same elements. And this is how it's represented visually with the Venn diagram. Relationship 2, proper subsets. So set A is a proper subset of set B. This is how we'll denote that. When every element of A is also an element of B, so from the diagram we can see that set A is completely inside of set B, and B has at least one element in it that is not an A. So in this space right here, between the two circles, that will represent the elements that are in set B, but not in set A. And this is how it would be represented in a Venn diagram. Relationship 3, overlapping sets. So set A and set B are overlapping when they have some elements in common, and set A has some elements that are not in B, and set B has some elements in it that are not in A. And this is what it's going to look like. So you're going to have your one circle. Here's your circle for A. You're going to have your circle for B. And you can see they overlap right here. But in this region, this would represent the elements that are in A and not in B. And this region here would represent the elements that are in B and not in set A. So that's what it would look like with a Venn diagram if you had just like overlapping sets. And then relationship 4, disjoint sets. So set A and set B are called disjoint sets when they have no elements in common. So visually with the Venn diagram, you would just draw your two circles, your circle for A and your circle for B, in a way that there's no overlapping. Constructing a Venn diagram with two sets. So these are steps for how to create our Venn diagram when we have two sets. You're going to start with step 1, which is drawing this figure here. So you're just going to draw this figure exactly as it is. So we're going to assume before we start putting in elements into the regions, we're going to assume that set A and set B overlap. So you have this region 2. But we're also assuming that set A has some elements in it that are not in B. That's region 1. And we're going to assume that B has some elements in it that are not in set A. That's our region 3. And then we'll have a region 4, which is outside of both sets A and B. And then step 2, you're going to complete the region where the two sets overlap. So you're going to start, basically we're going to like work our way from the inside out. So we're looking at the most overlapping parts first and working outwards. So you're going to start was region 2. That's this region right in here. Then step 3, you're going to work on the non-overlapping regions. That's going to be regions 1 and regions 3. So region 1 here and 3 here. Then you're going to complete the region that's outside both of those sets, which is your region 4. So we'll go over a couple examples so we get an idea of how to do these. So for part A, we're going to start with the rectangle. We're going to call it U, and we're going to draw 2 circles that are overlapping. So here's my set A, and here's my set B. Okay, so we're going to start with region 2, which is this part here where the 2 sets overlap. So for part A, our universal set, all the elements that we're concerned with, are just the integers 1 from 10 inclusively. And then set A contains the elements 1, 2, 3, 5, and 7, while B contains the elements 3, 6, 7, and 9. So to figure out what's in region 2, you're looking for what elements are in both set A and in set B. And it looks like that's going to be your 3 and your 7. Those are elements that are in both sets. So you're going to write those elements in this region 2 where the 2 sets, the 2 circles, overlap. Then you're going to work on regions 1 and 3. So you're going to look at, I'm going to look at region 1 first, and that's just going to be the elements that are in A that are not in B. And this is going to be 1, 2, and 5. So I'm just going to write 1, 2, and 5 here in that region 2. And then region 3 is going to have 6 and 9. Those are the elements that are in B, but not in A. Now, at this point, a lot of students will stop, they'll move on to the next problem, but remember, you still have this region that's outside both of these circles, this region here, which is region 4, so you still have to do that. So we've included 1, 2, 3, 5, 6, 7, and 9. Those are already in our Venn diagram, but we still have 4, 8, and 10 that are in our universal set that are not in set A or in set B. So those are just going to go on the outside of those 2 circles. So 4, 8, 10. I'll just write them over there. And then we're done. So this was relationship 3 with the 2 overlapping sets. Now we're going to get ready to do part B. So we'll draw our 2 circles. We'll put U somewhere and label these circles as A and B. And we're going to start with that overlapping region first, region 2. So we're looking at sets A and B here and seeing if they have any elements in common. So it looks like they both have an A, they both have the B, and they both have E. So all those elements are going in the overlapping part, A, B, and E. And then we're done with set A, right? We've already included everything from set A. So then let's see if there's anything else in B that we don't already have written down, and that's C and D. So C and D are going to go over here in region 3 because they're in set B, but they are not in set A. And then we're not done yet because we have to make sure we include all the elements from the universal set. So we've already included A, B, C, D, E. F and G, though, we're missing. So we're just going to put that F and G just somewhere in the universal set, somewhere in the rectangle, but outside of both of those circles. And this is actually your proper subsets. That was relationship 2. This is fine. You can leave it like this in the homework and on the test once you have it filled in. But I'm just going to go ahead and show you how you can rewrite it too if you want it to. Because now that we see this, we know that set A is completely inside of set B. So set A is a proper subset of set B.
Testing, testing.
Constructing a Venn diagram with 3 sets. So you're going to start with the following drawing here, this Venn diagram. So you're going to have your rectangle for the universal set, and you're going to have 3 circles that are going to be drawn in a way so that all 3 of them are overlapping in one region. And that's going to be this region right here. And then you're going to label regions 1, 2, 3, 4, 5, 6, 7, and 8. You're going to have 8 regions. So that's the first thing. You're going to start with that image. Then for step 2, you're going to complete the region where all 3 sets overlap, which is region 5. So you're going to work your way from the most overlapping portions outward. Step 3, complete the regions where 2 sets overlap. And that's going to be regions 2, 4, and 6. Here you have 2. Here you have 4. Here you have 6. Then you're going to complete the non-overlapping regions. So regions 1, 3, and 5. Region 1, region 3. Did I say 5? That should be 7. Region 7. And then you're going to complete the non-overlapping regions of sets. So that's going to be regions 1, 3, and 7. 1, 3, and 7. And then complete the region that's outside all of the sets, which is your region 8. Example 2, construct a Venn diagram for the following sets. So we're going to start with the rectangle and draw the 3 circles for the 3 sets. This is our universal set right now. So the universal set is just the integers 1 through 12. And then we have set A, set B, Example 2, construct a Venn diagram for the following sets. So we're going to start with our rectangle first. This is our universal set, which is the elements, the integers 1 through 12 inclusively. And then you're going to draw your 3 circles for the 3 sets. So there's set A, set B, and set C. And then we're going to start with this innermost region right in here. So we're looking to see where all 3 sets, A, B, and C, where all of them overlap. So is there an element that's in all 3 of those sets? And we do have the element 1, that's in all 3. And so is the number 3. That element is in all 3 sets. So we're going to put a 1 and a 3 inside there. And then just be careful, try to like separate them a little bit, maybe even more so than I have it, so it doesn't look like a 13. So it should be a 1 and a 3. Or maybe write 1, 3 and put a comma between them. And then we're going to look at the regions where just 2 sets overlap. So I'm going to look at this region here where A and B overlap. Are there any, besides 1 and 3, are there any other elements that are in both A and B, but not in C? And this is going to be number 5. I'm going to put that there. And then there's no other elements. So then I'm going to look at where A and C overlap. That's this region here, A and C. Are there any other elements that are in both A and C, but not in B? And that would be 7. And then over here where B and C overlap, are there any elements in set B and set C that are not in A? And this would be 8. Oh, and also 2, missed 2. And then we're going to look at the non-overlapping regions. So is there anything else in set A that I don't already have included? So on my Venn diagram, I have 1, 3, 5, and 7. But there's also a 9 that's in set A. Then for set B, I already have 1, 2, 3, 5, and 8, but there's also a 4 and an 11 in set B. So I'll put that in this region that doesn't overlap with any of the other sets. And then what about set C? That also has a 10 in it. So it's going to go down here in the part of set C that doesn't overlap with A or B. And then just make sure we've included on our Venn diagram all the elements that are in the universal set. So we already have 1, we have 2, we have 3, we have 4, we have 5. Do we have a 6? Nope. So I'll put that outside all the 3 sets. 7's on there, 8's on there, 9's on there, 10, 11. And do I have 12 on there? No. So we'll put 12 here. And then I think I have all the numbers, all the elements that are in that universal set. Example 3. Different approach to our Venn diagram. So now we're not constructing it, but we're going to just use a Venn diagram to interpret some information. So a group of friends is ordering a pizza. They wrote down what toppings they want. We're going to use this information and the Venn diagram to determine in which region Max belongs. So your universal set is the set of all pizza toppings. And then let's just make sure we understand this Venn diagram. So we have 3 circles, one for pepperoni, one for olives, and one for mushrooms. So this is the circle for pepperoni. So region 1 here would be someone who just wants pepperoni on the pizza, but not olives and not mushrooms. Region 2 would be someone who wants pepperoni and olives on the pizza, but not the mushrooms. And then region 4 here, where pepperoni and mushrooms overlap, this would be people who want pepperoni and mushrooms, but not the olives, because this region 4 here doesn't overlap with the orange circle representing olives. And then region 5 here, this is where all 3 toppings overlap. So this would be the region, this represents the region for someone who wants all 3 toppings, pepperoni, olives, and mushrooms. So Penny, for example, she said yes to pepperoni and yes to olives, but no to mushrooms. So she's somewhere over here in region 2. Dave said no to pepperoni, no to mushrooms, but yes to olives. So he's over here in region 3. Alex said yes to pepperoni and yes to mushrooms, but no to olives. So he's over here in this region, region 4. So now Max, what region is Max in? So Max said no to pepperoni, but yes to olives and yes to mushrooms. That's going to put him over here in region 6. So Max belongs to region 6. So this is just a Venn diagram to show the relationship between some of the common sets of numbers. So we have all these real numbers, and they're broken down into 2 categories, either rationals or irrationals. So your rational numbers are going to be numbers that you can't write as a fraction. It cannot be rewritten as a quotient of 2 integers. It's going to be a number that is written as a decimal that never repeats and never ends. On the left-hand side, the set of integers is inside your set of rationals. As a reminder from the previous chapter, your rationals, that's going to be a quotient of 2 integers. That's a rational. And then your integers are a subset of the rationals because every integer can be rewritten as a rational by taking that integer and writing it over 1. And then the whole number is a subset of your integers. So your integers can be positive, negative, or 0. Whole numbers will contain 0 and then positive integers. And then your naturals are going to be your positive integers, which are like your counting numbers 1, 2, 3, and so on. So let's put some elements in here just as an illustration. So an irrational would be like e, pi, and I'll come up with some other number where here it never repeats and it doesn't terminate. Or maybe square root 2. That can be in there also. So those are examples of irrationals. And then your natural numbers, I'm going to work from the innermost set outward. So naturals would be 1, 2, 3, and so on. The whole numbers would contain 1, 2, 3, and so on, but also 0. And then your integers would contain the 0, the 1, 2, 3, and so on, but also your negative integers. So I'll do -1, -2, -3, and so on. And then the rationals would include all the numbers I have written down so far, your natural numbers, the whole numbers, the integers, but also quotients of integers. So let's say 4 sevenths, or -11 halves, or 1/3. So those are some examples so you can visualize that. Venn diagrams will continue to be discussed again in the next section, but we're going to look at the Venn diagrams along with set operations. And then we're done with this section, so make sure you do the homework, and I'll see you in the next one.